Hi everyone, I'm Tracy Delgado, and today we're going to do Module 2, Chapter 9, Geometric Figures. And my joke for today is, why was the mathematician late for work? He took the rhombus. So let's get started with our lesson. We're doing question number 1. We have parallel lines right here, and these two lines going down this way. I'm going to explain what vertical angles are. Vertical angles are pairs of opposite angles made by intersecting lines. And the vertical angle theorem states if two angles are vertical, then they are congruent. So these two angles right here are going to be, these two lines right here are going to be vertical. So that gives us vertical angles through here. And in stating our question about explaining similar complementary and supplementary angles, I will now explain to you about complementary angles. They are angles that add up to 90 degrees. Supplementary angles are angles that add up to 180 degrees. And in our question, these angles here, this one was already given to us as 63 degrees and 61 degrees for this one. So by process of elimination, this angle will add up to be 180 degrees in total. So we will add up 63 plus 61 gives us 124. When we subtract 180 from 124, that gives us 56 degrees. So as I've seen in our chart right here, number 7 is 56 degrees. And we can go and look and see what similar angles we have. Angle 1 will also be 56 degrees because it is very similar to angle 7. Angle 2 is right opposite of this one. It looks the same, so we have 63 degrees here. Angle 3 appears to be the same as this one, is 61 degrees. Angle 4 is also going to be 61 degrees. Angle 5 is 56 degrees also, because it's the same as 1. Angle 6, since 4 was 61 degrees, we're going to take 180 and subtract 61 from that, and that gives us 119 degrees. Angle 7, as we stated, is 56 degrees. Angle 8, angle 5 was 56 degrees, so we're going to do the same thing. 180 minus 56 gives us 124. Angle 9 is congruent with this one, so it's 61 degrees. Angle 10 is going to be 119 right here. Angle 11 is going to be 124 degrees, and angle 12 will also be 56 degrees. And in our chart right here, we're doing the similar angles. It's going to be angles 1 and 5, 2 and 63 degrees, angles 3 and 4, 6 and 10, 7 and 12, 8 and 11, and 9 and 61 degrees. Our supplementary angles are going to be angles 1, 2, and 3. They all add up to be 180. Angles 2, 3, and 5, same thing, 180 degrees. 2, 1, and 4, 180. 6 and 9, 7 and 11, 7 and 8, 8 and 12, 9 and 10, and 11 and 12. And if you've noticed, I haven't mentioned complementary, and there's a good reason for that. There are no complementary angles because none of these add up to 90 degrees. And now we will move on to question number 2. We have this triangle right here, and we have this shape right here that, if you want to think of it as a rhombus, it does resemble a rhombus. And this one we were given 26 degrees here and 74 degrees here. And the question is, we're supposed to create a chart. It's going to be the same thing that we did in the previous question, similar complementary and supplementary angles. So in this one, I come up with 80 degrees for angle 1. Angle 2 was 100 degrees. I'm so sorry about this. I forgot to explain that if you drew a line right here, this would make 2 equal triangles. So now I'll get back to my explanation. Angle 1 will be 80 degrees. So that angle 2 will be 100 degrees. That would give us our 180. Angles 5 and 7 will be the same thing. Angle 7 will be 100, and angle 5 would be 80. In this one, we will have 74 We already gave 74 given to us. So angle 3 would be 80. And if we do 80 plus 74 gives us 154. So angle 4 would be 26. Angle 6, we already have 26 degrees, excuse me, right here. So angle 6 would be 74. And if we do 74 plus 26 gives us 100. So 8 will also be 80 degrees. And when we look at our chart here, we have similar angles, excuse me, will be 4 and B, 6 and C, 3, 5, and 8, 2 and 7. Our supplementary angles will be 1, B, and C, 2 and 3, 3, 4, and C, 7 and 8, 6, 8, and B, and angles 4, 5, and 6. And we have the same issues we had in the previous problem. None of these angles add up to be 90 degrees, so there are no complementary angles in this question. And the next one, we have this lovely little shape right here, and we have given these two angles already. And this one, this shape I should mention is called a concave polygon. And in this one, we're going to find the measures of the angles. And first, we need to determine how many sides we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So our N is going to be 8 sides. To find the answer to our questions, we need to do the formula N minus 2 times 180. And in this case, our N equals 8. Okay, so we'll do 8 minus 2 times 180. So that would be 6 times 180 equals 1080 degrees. And when we do add up all these numbers, we have 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus, well, this is 37, it should be 3y plus 12y equals 1080 degrees. And when we add all these up, it will be 54y equals 1080. And when we divide both sides by 54, it gives y equals 20 degrees. And when we're doing 3y equals 3 times 20 right here equals 60. Our 7y's equals 7 times 20 equals 140 degrees. And our 12y equals 12 times 20 equals 240 degrees. Question number 4 is this lovely little shape. I hope I didn't jack up the design too much. I apologize. I'm not an artist. I'm not a natural artist. So this object is called a nonagon. And we were already given this line right here. And if you look at it, it looks like a piece of pizza. That's how I would think of it. And we have angles right here that we need to find out what these angles are. We're supposed to find out the measures of the interior, exterior, and central angles. And if we're going to do, the formula is internal angle plus external angle equals 180 degrees. An internal angle is simply what it says. Internal means inside, the angle's inside. And our external angles, exterior angles, will be these, this one represented out here on the outside. And our central angle will be exactly what it is, this one right here. In the process to solve our problem, we do the same formula in a way. We do n minus 2 times 180 divided by n. And this one, we do the same thing about determining how many sides we have. And on this one, there's 9 sides to this shape. So it would be 9 minus 2 times 180 divided by 9. So we have 7 times 180 divided by 9. And 7 times 180 is 1,260. We divide that by 9, and we're given 140 degrees. The next way to solve the interior angles, I believe, or do I have it wrong? It's our exterior angles. I'm so sorry. Our exterior angles are 360 divided by n. And we do 360 divided by 9 equals 40. And surprise, surprise, to find our central angles, we'd use the same formula. 360 divided by 9, and that gives us 360 divided by 9 equals 40 degrees. Now question number 5, we're given this lovely little box right here. And these are internal angles right here. And this one we're supposed to construct 3 of the faces of the tetrahedron DEGH as subsets of the faces of the cube, which means that the tetrahedron inscribed in the cube has none of its faces in the planes of the face of the cube, and none of them will overlap. So what we're going to do is this one, we're going to connect D to E, E to G, and G to D. And that gives us our triangle right here in the middle of our tetrahedron. And last but not least, we're doing a picture of a tetrahedron, an octahedron, and an icosahedron. I'm so sorry about butchering that name. I've never heard that word in my entire life. This lovely figure right here is going to be the tetrahedron. It has 3 sides and a bottom, so it has 4 sides to it. Our octahedron is going to be basically the same shape, except this time it has 4 internal triangles right here. And our icosahedron is 20 equilateral triangles. And I chose these beautiful colors, so hopefully it'll make it stand out. And that will conclude my lesson. I hope you enjoyed it. I hope I didn't bomb this lesson, Ms. Benzie. Thank you for watching. Bye.